My name is Will Steffen. I'm an Earth System scientist based in Canberra, Australia, with the Australian National University and with the Climate Council of Australia. I spent much of my career working internationally with the International Geosphere-Biosphere Program based in Stockholm, Sweden, but working around the planet with many other scientists, understanding how our planet works, how humans are changing it, and what futures we may or may not face as we go forward. Climate Change 2021, why are we facing an emergency? Well, most of you know that the IPCC Sixth Assessment Report has just come out, and its message is clear. Climate change is happening more rapidly than we anticipated, and it's becoming more dangerous. So I think all the evidence is there that we are indeed facing an emergency, and we have to act as if we are facing an emergency. This is an image of where I sit, Canberra, Australia, January 2020, a year and a half ago. And you can see the enormous flames coming down the hills right behind the city, bearing down on the city. It was a frightening experience, brought back memories of 2003, when fires actually did come in and destroyed about 500 homes, killed 4 people, and so on. Fortunately, we had a wind shift and avoided that this time. But around Eastern Australia, late 2019 and January 2020 were horrific. The worst bushfires on record. We burnt 20% of the forest of the entire Eastern Australian forest biome. About 450 people were killed either directly or from the smoke. And it was just an unprecedented event. And there's no doubt that climate change was the main driver of that event. We had record high temperatures in 2019, and 2018, 2019 were the driest on record in Southeast Australia. Both of those related to climate change. But it's not only Australia that's being hit by extreme weather. This is 2021 with a massive heat wave in North America, primarily hitting the western part of Canada. Temperatures well up into the 40 degrees, unheard of in that far north. And if we switch to Europe, again, this year, earlier in 2021, massive floods swept through parts of Germany and Belgium, again, killing a large number of people, wiping out many homes and other infrastructure and so on. And there is no doubt that these extreme weather events, be they extreme heat in Canada, be they floods in Germany or China or India, climate change is the main driver behind all of these. So indeed, it's not just the scientific data which is telling us that we have a climate emergency. It's actually the on-the-ground events that are happening around the world and that are being experienced by millions of people that are telling us that we have to act swiftly and very dramatically if we want to get the climate system back under control. This is the data behind those extreme weather events that we're experiencing around the world. This is a temperature record for the Earth as a whole. It's the Earth's surface temperature averaged over land, ocean, and ice. Starts in 1850. You can see on the left-hand side here of the diagram. And it's pretty steady climate, a little bit warming until about 1970. And then we've had an explosion of temperature rise during that time, reaching about 1.2 degrees above the pre-industrial average by 2020. Again, these types of temperature records are unheard of for many centuries. So the 2020 average was a full 1.2 degrees above pre-industrial, and it was one of the 3 hottest years on record since the World Meteorological Organization has kept records. But even more dramatic is if we look at that temperature rise in a much longer time scale. So this graph goes back to 2,000 years ago. So this is AD 0, or about the time the Roman Empire was at its peak. And we can go through the Middle Ages, were somewhere around here. Industrial Revolution started about in here. But the point I want to make is that Earth's temperature has been very steady. These colored lines are averages of the temperature records through that time. And you see they only vary by about 1 or 2/10 of a degree, hardly noticeable. But this black line, this huge spike at the end, is the human-driven change to temperature. That's due to the burning of fossil fuels, coal, oil, and gas. And again, this spike only begins around the middle of the 20th century. So when you look at how dramatic this is compared to the past, you can understand why we're seeing such extreme weather events like the fires in Australia and California, the heat in Canada, and the floods around the world. And we can see it in the devastation it's causing for the natural world. The fact that there are many animals and ecosystems which are suffering because they simply are not adapted to temperature rise this much and this fast. The rates of change are dramatic when you look at it in an even longer point of view. So if we look at how fast carbon dioxide is increasing in the atmosphere, and that's the main driver of these temperature increases, over the past 2 decades, it's increasing at about 100 times the maximum rate during the last time the Earth came out of an ice age, and that's when CO2 went up about 80 parts per million at a very fast rate, but nothing compared to the rate that it's going up now. This temperature rise I showed you from 1970, that's about 200 times faster than the very slow cooling of the climate from about 7,000 years ago, about the middle period of the Holocene, the geological epoch that we've been in up until recently. But the last comment here from the Geological Society of London, I think, is the most dramatic. These rates at which temperature and CO2 are rising are almost unprecedented in the entire 4.5 billion year history of Earth. So these are incredible changes to Earth's climate system, and there's absolutely no doubt that they are driven by human activities. The real worry, though, the real concern, in addition to all the extreme weather events that I've talked about, the heat, the floods, the fires, and so on, is that ticking away behind those events are some other features of the Earth system which could really cause a lot of problems. These are so-called tipping points. They're parts of the Earth system, like ice sheets and sea ice, like ocean circulation, like big ecosystems like the rainforest. These are starting to change, being driven by climate change. We are losing ice at an accelerating rate. The Atlantic Ocean is slowing down. Permafrost, the frozen carbon up in Siberia, is starting to thaw. We've had massive die-offs of coral reefs. The Great Barrier Reef here in Australia, it's about 50% dead already. And the Amazon is suffering increasing droughts and therefore more prone to burning. All of these so-called tipping points are being activated because the climate is shifting. But I think even more dangerous than they are on their own is the fact that they are linked. For example, as you melt the Arctic sea ice, that uncovers more darker water. In the northern hemisphere summer, that absorbs more sunlight, increases the heating, increases the ice melting on Greenland, pouring more fresh water onto the Atlantic, slowing the Atlantic circulation, creating more drought in the Amazon. And you can see that sort of like a row of dominoes, that when you start pushing one, it can knock over the next one and the next one. We could get what's called a tipping cascade going. Now, the reason this is dangerous is because a lot of these processes themselves warm the climate. As permafrost thaws, it emits carbon dioxide and methane. As Arctic sea ice melts, it heats up the planet because it uncovers more ocean water, and so on. So the problem here is that once this cascade gets going, it basically takes the climate system out of human control. And we can get our own emissions down, but the climate will continue to warm, continue to change, extreme events will continue to get worse, and there will be pretty much nothing we can do that's going to slow or stop this. So this is really the most dangerous part of climate change, is if we activate this, we will lose control of the system. Where might this occur? We don't know, but we know that the risk that it will escalate sharply the further above 2 degrees warming that you go. Now, why is all this happening? This is happening because we are emitting carbon dioxide from our use of fossil fuels primarily. About 90% of our emissions come from coal, oil, and gas, about 10% from land use change, deforestation. So going again back to 1850, emissions were very low. But notice that this curve is sweeping upward. These are observed emissions to the point where we are now over 40 billion tons of carbon dioxide in our annual emissions, and that's growing year by year. There are little blips here and there, and COVID is creating a little blip right now. But even as we're talking in 2021, emissions are going back up compared to 2020. So that's the dilemma that we face. We have to get emissions back down to zero within the next 2 or 3 decades to have a chance of stabilizing the system. So on this graph, 2 decades would be out about here, 3 decades about here. So that means we have to have extremely steep reduction curves. So that red arrow I've put there, that's what we need to do in terms of the magnitude and the rate of getting our fossil fuel emissions out of our economic systems. That's what's required to stabilize the climate system at anywhere near a level that we can survive or thrive in. And this is the climate emergency. The students are right that this takes an enormous effort, a very fast effort, and we must cut our emissions very, very deeply. So that's the story. We are at a fork in the road. It is an emergency. We need to act now. The climate evidence is absolutely clear. The system is moving at rates that are unprecedented in virtually all of the history of Earth. We know why they're occurring. They're occurring because we are emitting CO2 from the burning of fossil fuels. We have the alternatives now in renewables and other new technologies, but we have to get onto the job fast. We have to start moving immediately to get our emissions moving towards zero as fast as we can. Thank you very much.